Hey everyone! Today we're diving into advanced functional programming. Concepts like higher-order functions, currying, and composition are powerful but can be difficult for developers not accustomed to a functional programming style. By the end of this tutorial, you'll understand how to use these techniques to write cleaner, more maintainable code. Let me explain the concept of higher-order functions. Higher-order functions are functions that operate on other functions. They can take one or more functions as arguments or return a function as their result. This enables powerful function composition patterns that we'll explore later. Next up is currying. Currying transforms a function that takes multiple arguments into a sequence of functions that each take a single argument. This allows us to create specialized versions of functions by fixing certain parameters. Finally, let's talk about function composition. This is the process of combining multiple functions together to create a new function. The output of one function becomes the input of the next, creating a pipeline of transformations. Now let's look at the code on your screen. This is a higher-order function called multiply_by. It takes a factor as an argument and returns a new function that multiplies any number by that factor. We then create specialized functions double and triple. Here's an example of currying. The add function takes one argument at a time. We first call add with 5, which returns a new function. Then we call that new function with 3, resulting in 8. This shows partial application using bind. We create a new function sayHello that always uses hello as the greeting, while keeping the name parameter flexible. Here's function composition in action. We have two simple functions, add1 and square. We combine them into a new function add1 then square that first adds 1 and then squares the result. For more complex cases, we can create a compose helper function. This takes multiple functions and returns a new function that applies them in sequence from right to left. Let's see this in action. If we input an array of 1, 2, 3, our pipeline first adds 1 to each number, then squares them, resulting in 4, 9, 16. Let's compare the imperative approach with a for loop to the functional approach using map. The functional version is more concise and declarative, expressing what we want rather than how to do it. A common mistake is trying to curry a function that takes multiple arguments at once. The correct approach is to nest the functions properly, as shown in the right example. Another mistake is getting the composition order wrong. The functions are applied from right to left, so the order matters for the final result. Here's a pro tip. Use arrow functions for cleaner syntax when working with higher-order functions and currying. They're more concise and maintain lexical binding. Another tip is to keep your functions small and focused on one task. This makes them easier to compose and reuse. For more complex projects, consider using libraries like Ramda or Lodash/FP. They provide many functional programming utilities out of the box. Let's look at a more advanced example. We have an array of user objects. We create 3 simple functions to extract ages, filter adults, and calculate average. Then we compose them into a pipeline that processes the data in one clean operation. In the real world, these techniques help standardize and validate data before processing. The pipeline approach makes the data transformation process clear and maintainable. While functional programming offers cleaner code, it's important to be aware of potential performance considerations. In many cases, the performance difference is negligible, but it's good to understand the trade-offs. That's it for today. You've learned about higher-order functions, currying, and function composition. These techniques can significantly improve your code quality when used appropriately. If you found this helpful, please like and subscribe for more advanced programming tutorials. Happy coding!